But yeah, I am an alum from the chemistry department here at UIUC. I defended in August 2020. My PhD was focused on photothermal dynamics of heterogeneous semiconductor nanocrystals via ultra fast X-ray absorption spectroscopy, which is a mouthful. But a lot of my research was actually done at Argonne National Lab. So it's great to return back to a place that I have such a special connection to, but in a very different capacity. I'm no longer a research scientist. And what led me to this position as a business development associate was an internship that I did in graduate school through the Office of Technology Management, which we'll talk a little bit about how that internship works if you're interested. Was really pivotal and for me in discovering careers that I could use, really apply my PhD and stay close to research, but outside of the bench. So today we'll be talking a little bit generally about tech transfer and its background. When Jose calls in, he'll talk specifically about tech transfer at Oak Ridge National Lab, and then I'll talk a little bit about. Yeah, okay, he's here. Great. Awesome. Jose, do you want to go ahead and introduce yourself? I said a couple sentences about what I did my PhD in.
Awesome. Sure. Yeah. So my name is Jose Zavala. My PhD, I worked in the Jeff Moore group. I did a little bit of redox flow battery stuff, and then I focused on chemistry education. And then I even did a little bit of natural language processing with like a whole team of really good computational linguistic engineers. And now I'm a commercialization manager at Oak Ridge National Lab, and I'm having a lot of fun doing it.
Yeah, let's see, sorry. Change my... Okay, so we're both happen to work at U.S. Department of Energy National Laboratory. So in our positions that we're here to further the mission of the Department of Energy, which is to ensure America's security and prosperity by addressing its energy, environmental, and nuclear challenges through transformative science and technology solutions. So what that means for Jose and I is that we're really focused on taking all the great science that happens at these national labs and transferring it, tech transfer, into society in a meaningful way, whether that's commercializing a product or collaborations and partnerships with external groups of people like industry or university collaborations. So there's 17 DOE labs across the country, run by different offices within the DOE, as you can see here. Most of them are Office of Science run laboratories, including both Argonne and Oak Ridge, but there's a couple other offices, like you might be familiar with Sandia and Los Alamos. They are run by the National Nuclear Security Administration. So you can see they're pretty spread out across the country and all addressing the DOE's mission. So Jose, would you like to jump in here?
Sure, yeah. I think you're doing a great job. And I guess this stuff is not super tech transfer specific just yet, but, or are you looking at the tech transfer professionals while talking about slide?
Oh, yes, yeah. I'm not sure if you can see the screen.
No, I can't yet. I'm just
okay.
calling in, but
gotcha.
I'm following the slides that you shared, so
okay.
So yeah, what some of y'all might notice if you start going to tech transfer type talks, they always talk about the Bayh-Dole Act. Pretty much before this act was put into place, federally funded inventions belong to the government, which in theory makes them publicly available knowledge so everybody can make use of it. But what ends up happening is they kind of get locked away in a file cabinet and nobody has access to them really. So the Bayh-Dole Act allowed the acceleration of tech development by allowing universities and national labs to elect title to these inventions, which allows them to file patent applications on their inventions and also license those patents to private companies. And so that's kind of been like the driving horse for economic development out of labs and universities. It's what allows us to launch startups and work with private companies to make these academic curiosities into real life applications.
Absolutely. I've also read, and of course, maybe we're a little bit biased, but that this is one of the most inspired and successful pieces of legislation enacted in the country over the last 50 years. So some numbers for you. Before 1980, the US government owned about 28,000 patents, but only 5% of those had been licensed to industry. So by, like Jose said, making things publicly available right away sounds good in theory, but what that does is it doesn't allow for commercialization to occur. By having a patent and excluding the right of someone else to use your technology, it allows companies to develop that technology into products. And so let's see. I was just talking to Patricia about this, that I think one of my favorite aspects of the job is that we get to work with many different groups of people. I found that in grad school, I really liked working on different committees, like WCC was the main one that I was on. Jose and I were on DC-GSAC together. I really liked working in teams and with different groups of people. And so in a tech transfer career, you get to do that. You get to work with the scientists who are inventors. You get to work with patent agents and patent lawyers who are helping with writing the patents and filing them. And then you get to work with licensees. That's typically industry partners, but it can include a lot of different folks.
And yeah, I'll just chime in here. We're happy to talk more about any of this. If you're curious at all about it, no question is too small or too big. I really enjoy talking with the patent agents. They crack me up the way they're like elusive. If they don't like having their opinions written down on email, so they'll tell you to give them a call to give the spiel on a technology or something going on. So that's it's a lot of fun. But of
Very
course,
precise in their language.
Yeah, they are. and of course the since we're speaking to a group of grad students, the scientists of course are a lot of fun to talk to. It feels like grad school in a lot of ways. Sometimes when you're speaking with them, just the way that they approach problems, it's super creative and very technically oriented. So you get to talk pretty much 3 different languages. So it's a lot of fun.
Yeah, and I guess going along that line, it's a way to stay close to the research. But in contrast to grad school, where you're narrowing on really one very specific topic, by working at a place like Argonne, I work with a portfolio of many different technologies. So I get to learn about lots of different science. And it's really fun talking to the scientists because they might think about their science in one specific research capacity. But as a tech transfer professional, I'm talking to them and maybe trying to get them to think a little bit differently about their science, which is really fun. And like, okay, you're thinking of it for this specific use, but when we're writing the patent, we might want to think about, well, what other things could we use this for? Maybe you're thinking about this as a process, but we want to think about this as a specific composition of matter, or, something along that line. So it allows you to like learn lots of different science, but use your PhD creatively in getting inventors to maybe think a little bit differently. And so that kind of alludes to what it is that we do. Most of our work falls into 3 main buckets, but we do a lot of different other things. And that's first and foremost scientific and market research. So we gain a general and broad understanding of the scientific field, as I was just talking about. And that means that you need to learn about a lot of different science quickly and kind of know what depth you need to go into. You're not going to go into the scientist level of understanding on a technology that they've been, researching for 10 years, but you need to be able to drill in and find what are the details about the science that's important, what makes it novel, what makes it different, how does it compare to the cutting edge of the field. Is it a method? Is it a composition of matter? And then with that comes doing market research. So who else is doing this out there? How much money is there out there in this particular market for this kind of technology? And ultimately, who's going to pay to use it? Who's going to pay to develop and turn this into a product? And then we work with a lot of patent lawyers and patent agents to protect that intellectual property. Because we work with federally funded inventions, we need to ask the Department of Energy for rights to the inventions, and then we can file patent applications. And we can talk about that in more detail if you're curious at the end. And then a big part of what we do is actually plans and agreements. So where we do things like interinstitutional agreements, where you're collaborating with different universities. So like Argonne and UIUC might be working on a collaborative project together, and we'd set up an interinstitutional agreement to lay out, before the work is done, who's going to own what IP, what is that ownership going to look like, what are the outcomes for the project. We also do non-disclosure agreements. These are things that you want to keep confidential, particularly if you're working with a company who is working with confidential information that they don't want to get out there. And the final category, which is probably the biggest one that we work with, is sponsored research agreements, so cooperative research and development with external partners.
Yeah, and it's easy to get lost with all the agreements. There are a bunch of them, and the sponsored research agreements are, in the inventor's eyes, some of the most important ones. So like we at the manufacturing demonstration facility here down the street from Oak Ridge National Lab, they have it's like that entire building. It's a huge building, and it's filled with massive 3D printers, like massive ones. And they're all paid for, they're all cost shared with different 3D printing companies. And it's really cool to see industry and academia essentially working side by side on cutting edge technology. So that's kind of cool.
Yeah, absolutely.
But in order for all that to take place, you got to sign a bunch of contracts. That's where these agreements come into play. So it sounds maybe like a kind of a boring job to do because it's all, office work, but it allows the really cool science to happen. So this part is very important.
Absolutely. And so a big portion of what we do is evaluating the technology. So just to drill a little bit deeper, one level that the government uses to evaluate technology is a scale called technology readiness level. And basically this question is asking, is this ready to scale up? So there's a big difference, and you might realize this, between academic readiness and industrial readiness. So a pilot scale in an academic lab might be kilograms or grams even, whereas a pilot scale for industry is tons. And there's a lot more logistics that go into something that you do in your research lab versus doing it in a commercial plant. That even applies. Yeah, sorry, go ahead.
Well, I was just going to chime in and add in, in industry, a pilot scale plant means you have to actually build a plant that's cranking out this stuff, and maybe not selling it for a product yet, but figuring out how many people you need to hire for this, how many machines do you need, all the, how are you going to ship product, raw material in and product out. That's like a pilot scale plant in industry.
Yeah. Or if you're more on the device building side, it's one thing to have something that kind of works on your laser table in the lab, and it's another thing to have something that's a ready to go product for someone to buy that includes all the housing and the engineering, that it becomes like a tabletop device that you can package up and sell to others, versus something that you've got a bunch of wires sticking out and works well enough for your own experiments. And then in terms of patentability, this is huge. It's identifying what's actually novel about the technology. We love to use these words in papers, but it's looking at not just the scientific literature, but searching patent literature, which is you can find a lot of great information in the patent literature. And that's something I wish I knew more when I was in grad school, that's another source if you're looking for scientific information, that sometimes you can find things in the patent literature that you might not find in a journal article. And this is learning how to search for patents is something that you can do very quickly, because the same skills that you use to search for the literature translate to how you search for patents. It's just a little bit different, but you'll learn it very quickly. And then marketability, I think this one is the most fun. It's what I personally enjoyed the most, is thinking about who cares about this? What's the value proposition for this technology? To whom does it provide value? Who's going to be interested in this? And in some ways, when you're working with really early stage technology, you might be working in a very niche market. Think about electron microscopes. They're very expensive technology, but not a ton are sold worldwide. But if you can come up with a great development, they are millions of dollars sometimes. So by being a scientist who has used these, you can kind of understand, well, okay, I know the major makers of electron microscopes. I can look up to see how many are made per year. I can see what the cost is, and then you can kind of get creative in terms of figuring out what the market is. Or you can search market reports. That's kind of the main way. But when early stage technology, you get to be a little more creative in figuring out the marketability.
Yeah, totally. And then kind of in addition to this, just like a plug, I guess, the NSF and like the DOE, and there's a lot of interest in getting scientists, like hardcore scientists, to think about the marketability of the technology. So there are programs like NSF I-Core, Innovation Core, and Energy Innovation Core, which they do cohorts every year, and their goal is to the whole program is scientists that think their stuff is ready for a startup, maybe put in an application and then get to join a cohort and learn about how to find the value of their technology. Who would buy this? Does everything just get sold? Would this be useful to sell to like Dow or something, or maybe one of Dow's suppliers? There's a whole lot of it's a whole other different type of research, doing market research. So
yeah, absolutely.
Chiming in.
Yeah, no, thank you. So this is how to prepare. So Jose and I both did the internships that I mentioned at the beginning with the Office of Technology Management. So it's great timing for this talk because it's October, and so applications open up in January, which is going to be here before you know it. It pays pretty well. I think it's $21.50 an hour. You work as a PhD candidate 10 hours a week. This key detail about working 35 hours a week for the first 2 weeks, that's also really flexible. I was on fellowship, so I was not able with the rules of my fellowship to do the 35 hours a week, and I just did 10 hours a week for the training weeks. You'll be fine. Like, don't let these details keep you back from applying. I know a lot of people kind of worry about that. The major thing though is you have to get approval from your PI. So this is something you should look into now, and if you want to do it, it's the right time of year to be bringing it up to your PI. I brought it up to mine, right before winter break to say, hey, I'm interested in doing this. I'm going to prepare an application. Let me know what your thoughts are, and then in January we can revisit and decide if this is something that it makes sense for me to do in terms of the timing of where I was in my PhD. I waited till after prelim. I think that's generally the right thing to do, but of course it can vary based on your situation. So the commitment for this is that it's 10 hours a week for a year. So for me, it was great that I didn't have to leave campus to do an internship. So some folks you might hear do like a summer-long internship at 3M or Dow or things like that. But I was my advisor's first grad student. I couldn't afford to take off a whole summer from the program. So it was a way for me to get that experience without leaving the lab. If you're not able to do that, if that's kind of a commitment, or you're not quite sure if you're going to be around for another year, maybe you only have a semester left, you can look into Illinois Business Consulting. And this is a semester by semester basis. And I'll let Jose talk about this because he also actually did the IBC.
Yeah, I think IBC was a great experience. And I've heard from several other people that also did IBC that it really helps you. What I really took away from it was the ability to set up a problem space for some new type of problem. And so, you do this kind of stuff in research all the time, like how, what material would be good to replace lithium-ion batteries? Like, so then what's the problem space? What things should we consider, like energy density, the weight of the material, how easy it is to rip electrons out of, an atom? All that stuff goes into like an academic research perspective to developing the problem space. But then when you think about like if you're going to also build a business around the technology, you have to think about things like, well, where do we get lithium from? And you start to learn things like most of our rare earth elements come from like China. And so a lot of our magnet, raw material comes from China. So that means we have to figure out our own supply chain sometimes, or we have to figure out how we can, from where we're going to get the material to even build these kinds of batteries. So IBC, I think the coolest thing I took away from them was how to set up a problem space so that you can execute on this and also do it quickly. Like another thing that I noticed and took away from was everything happens super fast. The applications will be out 1 week, and then you'll have to, or the call for applications will be out 1 week, and then the next week or two maybe you have to have your application in, and then interviews are like the following week, and then everything is like super fast paced and like just quick and yeah, moves quick. Decisions are made fast, and they are like hard decisions. And you get to work with clients, like real life clients as well, and they have, you know, expectations of you, and they have them, you know, you need to meet deadlines for them, because a lot of these clients, they are not so much pinched for cash, but they are pinched for time. So you have to you have to take your scientific research skills and apply them to like a market research space, and answer real world problems for these clients and do it quickly. So doing that, I think it was super eye-opening, very exciting. You get to work with a lot of undergrads that you might think in the back of your head, oh man, working with an undergrad is going to be a pain in the butt. They're going to not take things seriously, but these are some very high-performing individuals, and really inspiring a lot of the time. It was a lot of fun working with this team of like really highly motivated people to solve real problems. And I thought it was a great experience. Everybody that I've spoken to from the chem department that also did IBC had a great experience doing it. And I can't recommend it enough. If you have any more questions about that, I'm happy to talk about it later after this talk.
Yeah, absolutely. I also, a resource that I wasn't able to take advantage of in grad school, but I wish that I had kind of figured out a way to do this, was the Technology Entrepreneurship Center. They offer on-campus and online courses and certificate programs for things like entrepreneurship for engineers or finance for engineers. These kind of skills that will be important if you want to move into more of the business world, use your science degree, but in more of the business world after grad school. And another resource that I realized a lot of people, like I didn't step foot onto Research Park until I did my OTM internship and they gave us a tour. But Research Park is here on campus. It's a technology hub for corporate research and startup companies, including Enterprise Works. And they offer a lot of career fairs and like resume prep and like different free resources that I definitely recommend that you go to. The engineering career fair is a great resource, of course, but it's huge. So I found that the Research Park career fair was like a nice, smaller, more intimate career fair that wasn't as intimidating to help get me ready for things like the engineering career fair. So that's another resource I wanted to plug. There's different ways to get into a tech transfer career post-grad school. Like you can do the internship. There's different fellowship programs, one through a program called Life Arc Autumn, which stands for the Association of University Tech Managers. Different universities offer tech transfer postdocs or fellowships. For example, I know University of Minnesota, Twin Cities has one, University of Michigan, which Jose and I have a colleague from grad school who did that fellowship and now has a full-time permanent position there. And other places. So you can look on the Autumn Career Center website, and this is where you're going to see job postings for associate positions where you can join with maybe just a PhD background and haven't had any of these skills yet, or if you want to really take a chance to learn them, you can look for these postdoc type positions. And we have a couple alum from the chemistry department that we just wanted to give a quick shout out to that also did the OTM internship, but took the more patent agent path. That's Effie Zhao and Zach Wiersma. Effie's a scientific advisor at a law firm in California, I believe. And Zach Wiersma is a patent agent who's currently in law school to get his full-on JD at a law firm in the St. Louis area, I believe. And then there's a couple opportunities that I found just a couple days ago that are currently hiring that I wanted to shout out. I think Patricia will send these slides so you can get all the links. But after grad school for a year, I was actually in this position at the Institute for Genomic Biology here at UIUC. I was an economic development fellow. And so now they're currently hiring for this position. So take a look at the job ad there. I think a lot of folks in this audience would be highly qualified. So if you're getting close to graduation, there's a lot of great benefits to being a postdoc at IGB. You get a nicer salary because it's an IGB fellow position, and some other great benefits. So check it out. And if you have questions about that, because that was my previous role, I helped develop it. Feel free to reach out to me afterwards. I think we have our emails, but I can send them in the chat too. And then this is another cool opportunity that I got in I think a Women in Bio mailing list just the other day. The Chicago Biomedical Consortium has a Entrepreneurship Fellow Award. So if you're a recent PhD grad or MD or even master's postdocs, it looks like all sorts of advanced degree levels, and you're looking to learn the business of biotech and transform your science into some sort of technology, applications are open currently. It looks like they just opened on the 15th and will close about a month from now. So feel free to check that out. And with that, I'll let Jose talk about tech transfer at Oak Ridge. Jose, if you just want to let me know when to go to the next slides, I can do that for you.
Okay, sure thing. I think we're probably going to fly through these so we can leave like plenty of time for questions afterwards. So let's hop into it. Let's go to the next slide. I think it should be a picture of Ornell.
Yep.
That's our visitor center there. If y'all haven't been there before, it's really pretty here. It's you can tell it's like fall because the trees on that ridge back there are turning orange and yellow. Super beautiful out here. And in the morning, it gets super foggy. That's what they call it, the Smoky Mountains. So Ornell is covered in like this really dense fog in the morning. I personally love it. I love foggy weather. Let's go to the next slide, please. These are huge numbers. Ornell is a leading science. I think it's like the highest budgeted of the national labs. I think 2.1 billion in fiscal year 2020, but I think it was like 2.2 or something in 2021. Big numbers. They solve big problems, so we need a lot of numbers to solve them. So let's move on to the next slide. Yeah, more big numbers. Big numbers solve big problems. Let's move on to the next slide. I like this. This one should be a map of the world with a bunch of yellow buttons and blue buttons. So this is just a map of where we have CRADAs, executed, and also licenses and user agreements. I would like to point out the licenses. We have a lot of them, and just a quick fact that some of you might be thinking about, since these are DOE-funded inventions. Are we allowed to license them like internationally? And the answer is yes. You just have to fill out a little bit more paperwork because DOE typically doesn't like to, I guess, export what would be U.S. manufacturing jobs. That's kind of like the only restriction, or like the main restriction to think about when we're working with international partners. So that's kind of neat, fun little thing I learned. Next slide. The next slide is a juicy one, so we're going to spend some time on this one. Okay, so this one is the perks. So I was thinking, if I was a grad student, what would I like to know about this job? What would appeal to this job to me? So on the left, conferences. You still get to go to conferences, but they're a little bit different now. So AUTM is like the Association of University Tech Managers. I think that's what the acronym originally stood for, but now it's become kind of the organization for tech managers and the national labs and other institutions as well. So like universities and other institutions, and also the labs, like the Air Force even has tech managers, and so does NASA, and so does the CIA, actually, I learned recently. So that's AUTM. Next year is going to be in NOLA, which is kind of cool. And then also like more trade and industry focused conferences. So I'm encouraged to go to like an additive manufacturing one or like a carbon fiber one, because it's going to help me get very up to speed very quickly in the cutting edge of what we can do with carbon fiber technology like today, and what industry is working on for tomorrow. So I think that's awesome. And then the next column, always learning, one of my favorite things, why I decided to go and get a PhD. I really loved learning about the nitty-gritty science of what I was working on, but also I'm kind of more of a generalist, so I love learning a little bit about a lot of things. And so that, these days I work on, my portfolio covers carbon capture technologies and specifically direct air capture. So I learned a whole bunch about that. And then the director of my office also bought for a bunch of us a copy of Bill Gates' book, How to Stop a Climate Disaster. And that's helping me get very quickly up to speed on what's going on in that space. And then I get to have conversations with like data analysts and people at Dow. Dow is like carbon capture experts and their life cycle assessment experts. And I get to learn about the science and the market and industry of carbon capture. So I get to play my small role in helping to save the world. And I think that's awesome. Let's move on to the third column. So networking. Yeah, I get to talk with some of literally the smartest people in the world. They're right over here in this lab. I get to go eat lunch with them and try to ask them questions. It's a lot of fun. Franz is like one of our magnet experts. He's really good at a lot of things, but he has a lot of magnet IP. And then James Klatt gets to do a lot of really cool stuff. Some of his inventions are classified. That's kind of cool. And so I don't have security clearance, so I can't see the classified inventions, but I know he has them. And then we have like local entrepreneurs as well. So Greg Lamond is a bicyclist extraordinaire. He's won like Arc de Triomphe, or one of those races in France like 3 times. So he's like a big deal, and he has a bicycle company, and they're actually cranking out e-bikes right now. Really expensive e-bikes because they're super nice and incredibly light. But I got to go see his facility. That was really cool. And that's another entrepreneur there on the right. It's really fun to talk to them. They have a different perspective. They love science. Actually, Brandon's emails are full of e-chem puns, which I enjoy. But it's cool to see them like cranking out products with this technology. Super cool. And let's go to the fourth column, work-life balance. It's different from grad school, very different. But I guess kind of the infamous downside about working at a national lab is all the bureaucracy involved. But you can't really see it here, but it's pretty much that picture there is a list of all the names that I need to get a contract, an agreement to get approved by before I can actually send it over to the licensee for signature. And the point is there's a lot of names on the list. Some people are on there multiple times. So, the obvious downside is it takes some time to get things done. But the upside to that is there's a lot of forgiveness here. Like I can't make a fatal mistake, like if I was a physician or something doing surgery, I can't do any mistake like that. There's always going to be somebody double checking my work. So that's kind of cool. And then I guess we can go to the next slide. And here's another.
I'll just chime in here. So Jose's been on the job longer than I have. I started my position at Argonne 6 weeks ago, and I have to say I agree with him on most of these points. For me, having the work-life balance was really key. We don't take our work home with us after work. It's very, 8 to 5, 10 hours. And I think my advisor's first grad student. So that meant I had to make a lot of decisions like quickly and kind of on the fly and just hope that it was the right thing moving forward. So having all the structure of the bureaucracy, if you will, I find right now for me is great. I like having, you can't mess up. I have to go through, 5 different people to like make sure that I'm making this decision correctly. So at this point in my life, it is actually a benefit. Maybe later in life people see that as a downside, but when you're new in your career, it can be a positive thing.
Yeah, like the worst thing that I can do, I think I've learned is that so you file a patent, your patent gets approved, and it's like a legal document, but you have to pay a maintenance fee on it at 4, 8, and 12 years. And so every month we get these like Dennemeyer requests, and we have to decide, do I pay the maintenance fee or do I cancel it? And then the patent dies. And if that patent is actively licensed to some company and we don't pay the maintenance fee and the patent dies, then we can get sued by the company. That's like the worst thing that I can do. But other than that, it's not bad.
So then you have a couple slides here about, I think, examples.
Yeah, so these are success stories. So this is another like tech transfer trope. Tech transfer people love talking about success stories, and pretty much we could just flip through them. But the point here is we'll license to some company or have a creative with them, which eventually leads to a license, and that company takes that technology, they scale it up, they figure out all the kinks, to creating a product out of it and selling that product, to build a business model out of the technology, around the technology. And maybe like 10, I guess almost 20 years later, we'll sell a massive amount of products, and maybe the company will sell and to some larger company, and then we'll get paid out on a kind of our equity in that company, and that's like a success story. So you'll see a lot of those. Those are kind of like every tech transfer's dream, is to have like a really good success story, because that's kind of like our key metric, I guess, one of our key metrics. So we can just flip through.
Yeah, they'll get the slides. So if you guys want to do some Googling and read about these different success stories, we'll let you guys do that. And then I'll fly through my slides quickly here, because I do want to leave time for questions. So I'm going to talk a little bit about Argonne National Lab. It's going to complement a lot of the things Jose said. So I certainly don't need to spend a ton of time. So here's my email, cgentle@anl.gov, but I'll put it in the chat as well. So Argonne, Jose said that Oak Ridge has the biggest national lab budget. Well, Argonne can say that we were the first national lab. And we started in 1946 as a part of the Manhattan Project, with the mission of developing peaceful uses of nuclear power. So here's a little snapshot, a bunch of what the Argonne community looks like today. In grad school, I was one of the 6,700 facility users, and now I'm one of the 3,000 plus employees. So there's a lot of ways that research at Argonne is widely recognized. I just want to point out mainly the R&D 100 awards, and that there's thousands of inventions and patents that we've issued. We have a couple Nobel laureates that you might recognize. There's a lot of facilities here. So as a grad student, I came to use the synchrotron facility, the advanced photon source. But there's exascale computing that's being developed, and the Center for Nanomaterials. I do want to plug that. This is a really cool facility. So synchrotron, is really hard to get beam time there. It's a really unique facility. It's oversubscribed. But the Center for Nanomaterials has a lot more advanced but yet standard things, like different kinds of electron microscopes or scanning electron microscopes, laser systems, that kind of thing, which we do have a lot of at U of I. But if you're looking for something kind of specific, it's really easy to get a proposal through there, and you get to work with a staff scientist, and as a university partner, it's free for you. So do go check out their website if there's something that the Center for Nanomaterials could help with in terms of your research. Something that I found a lot of people didn't know about. And I did some laser experiments there in grad school. These are ways that we're trying to impact, that our office is trying to impact the Chicagoland area specifically, through collaborations and building the workforce of the US. And we add value we work across the value chain. So that means that we can go from discovery to scale up, to recycling. And so because we work across the value chain, we apply our capabilities and understanding of the whole value chain and iterations within it. And so what this means is that it creates touch points for partnerships with companies in various stages of growth, whether that's discovery to early product and technology development, all the way to later stage companies scaling up their technologies for broad commercialization. So all these capabilities under one roof allows us, and by extension our collaborators, to what's known as fail fast, which means you iterate quickly towards an optimal solution, which sometimes isn't always what happens in grad school. In grad school, typically you try for a long time to solve a problem, which works well at an academic pace. But in terms of commercialization, this concept of failing fast is really important. You want to know if something isn't going to work, you want to find that out quickly so you can move on to the next thing. And so here's a snapshot of our different industry partners. I won't dwell on this, but we work with a lot of different folks from all the way across from manufacturing to pharma. A fun fact here is that GE, General Electric, and Commonwealth Edison were actually our first industry collaborators. And in 1957, we developed the boiling water reactor, and we still collaborate with them to this day to make a versatile test reactor and other advanced designs. So that's a little fun fact about our industry collaborations. We have a long history of that. And this is, we talked a little bit about these, but just to reiterate how the ways that which research institute like Argonne works with industry, and that's ways through licensing the technology, either through patents or copyrights. And then we do collaborative research, and there's several different mechanisms by which that collaborative research happens. And it's the form of all these different agreements, which we won't get into the details of that for today. And these activities all have impact. So here's some impressive numbers of all the different patents. I think this is from FY 2020. And then if you're curious, like what do I mean when I'm talking about all these patents and things that are available for licensing, you can go to this website and click through Argonne's portfolio just to see what kind of patents Argonne has, and you might discover some things are kind of similar to the work that you're doing. So you might actually have something that is patentable as well that you're working on in your research as a grad student. This is one of our success stories. A huge portion, I think 30% of Argonne's portfolio is energy storage technology, batteries. And so there was a specific type of battery, nickel, manganese, cobalt, that has been one of the most successful technologies that was the basis of the Chevy Bolt and now the Chevy Volt. And so as you can see, we worked with BSAF, and this guy, Mike, commented that a lot of people are using Argonne's technology without even knowing it. And we fully expect they will be using it more and more. So that's something to look forward to in the future. And with that, I just want to highlight it is Argonne's 75th anniversary. So that's very exciting. We've been promoting that all year. And now we'd like to open it up for discussion, questions from everyone. I'll stop sharing.
Thank you both so much, Jose and Cece. And if you all have questions, feel free to unmute yourselves and ask those. Otherwise, you can also post them into the chat, and I'll try to help moderate that for you guys.
I guess I'll ask a question real quick. Can you guys hear me?
Yes.
Okay, I'll turn on my video so you can see me. So if thinking a little bit about like the job search process, I know you guys, you just talked a little bit about like the different resources you could look at to find these positions. How wide of a net did both of you cast? And then I know one thing that you've mentioned before, Cece, is that it can get confusing because these similar jobs have very different titles at different places. So how did you navigate that as well?
Yeah, so you'll notice Jose's title is commercialization manager. Mine is business development associate. I think at U of I's Office of Technology Management, they're called technology managers, and they're all, I mean, our jobs might vary differently, like subtly, but they're all basically the same job with very different titles. So when I was searching on LinkedIn, things like business development at like Verizon or McDonald's would come up, which are probably fine jobs, but like that's not the leap that I was trying to make. I was trying to do something in the scientific field. And so I found that the Autumn career site was really good for that because they specifically compile jobs for both like research institutions like the university, but you also see national lab jobs there. And because of my research background, I wanted to stay close to research. So you can get positions like this at different companies like 3M or Corteva. There's one alum from the OTM internship program that went to Northwestern as a technology manager, and now she is a technology manager at Corteva. So you can eventually do this same job in industry, but for me, I wanted to stay closer to the research because I felt more comfortable in that space. And so I focused on the career page at Autumn. But I'm curious for Jose, how did you manage your search?
I use the Autumn career site. There's just like everything out there. And yeah, I also wanted to stay kind of close to like research, but I wouldn't have been opposed to applying to like an industry position, like you said, CC. But yeah, I just scoured the Career Center website on Autumn. That's how I found my position.
Thank you. That's really helpful.
I will say the IGB Economic Development Fellowship that I mentioned, I held that position for a year, and that was really good for me in terms of developing those skills and then having a little bit more experience under my belt for applying for jobs. So I'm just gonna shout that out one more time if anyone's interested in applying. It was really instrumental and a big step for me. And so I put my email and then a link to this career site that we're talking about here. So Christina asks, how prevalent and competitive are these positions as compared to other positions such as faculty roles? That's a great question. I think I wanted to narrow my search to the Chicagoland area for family reasons. And so that made it a little bit hard. This is kind of a niche field. If I wanted to stay in like the university/research institution position, it's kind of akin to faculty jobs in that they're spread across the country. If you go to the Autumn website, you'll see that. But I don't think they're anywhere near as competitive. I think a big thing for me, and I talked to a couple folks, some of my mentors at OTM, I did my internship with, I was so stressed about the number of papers that I had in grad school. And for this kind of position, nobody asks about that. Nobody cares about your papers. Like, it's really important now for grad school, and the skills that you learn in terms of writing those papers are important. But for this career position, it's not like faculty job searches where it's like you need to have like a science and a nature and all these first author papers. I think none of that, those skills aren't necessarily relevant to this kind of job, and so it's not like an area of focus. So I think so to answer your question, I don't think they're nearly as competitive as faculty jobs. I don't know, what do you think, Jose?
Yeah, and I think, I think the algorithm that's important here is like speak to the audience, right? At a tech transfer job, they don't care about your papers. They want to know, can you negotiate? Can you talk with scientists and business folks and like translate between those, what they both care about? And, can you understand some patent law a little bit? The lawyers, if we're going to do all the lawyer stuff and the legalese, but you should be able to work with them. And so you really got to highlight those strengths that you developed during your grad school or whatever you've done previously in your grad school, and show the people here in tech transfer, like, maybe you can do this job.
So how'd you both do that on your resumes?
Yeah. Looking at I've heard this advice a couple times, looking at the job posting and finding the skills that they keep mentioning in that posting and highlighting those on my resume. Yeah, pretty much that I think is like critical. It's a good place to start.
Yeah, a big part of this job is, it actually is related to this question that's being asked right now, is relationship management. So learning how to work with scientists in a way that they'll tell you about what they're working on in a way that doesn't shut them down or discourage them, kind of keep them happy. Learning to work with lots of different people in order to get, there are a lot of steps involved in these processes and contracts and patenting things. And so you need to be able to manage across that whole operation. And so showing that you're able to collaborate with different groups of people. So you might talk about different collaborations that you had in grad school. And so for me, coming from an academic background, so to take a step back, this career path I think is really exciting because people come from all sorts of different backgrounds. So Zay and I kind of did the track right after grad school coming from an academic background, but in this position within your team and other technology transfer professionals, some of them come from 10 to 15 years of working in industry and then switching into this position. So what you want to do is highlight the skills that you have. And so for me, I find that as a fellow scientist, when I talk to different inventors, I try to relate to them by maybe connecting some piece of my research to what they did or what they're working on. So if someone had some quantum dot technology for like cancer, tumor detection or whatever, even though I didn't do biology stuff, I worked with photothermal dynamics of quantum dots. I'll say, oh yeah, I worked with quantum dots. And you'll kind of see this light go off where they start to trust you and they'll open up a little bit more. because sometimes scientists have the opinion that like, oh, these are just silly business people, they'll never understand my technology. But if you come in and you say, no, I have a PhD in materials chemistry, blah, 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 they'll be like, oh, okay, so I know that I can talk to you about the details of my science, and they'll open up a little bit more. So just learning about what skills do you have and how can you use that to establish credibility with whoever you're talking to, whether that's, you know, for us, it would be more that our academic experience.
Totally agree. And I want to highlight this job is a relationship management job. You need to be able to speak science with the scientists and to understand what they care about. And ultimately, like they're the outside, that's like the source of all the inventions that you're going to be filing patent applications on and then licensing. And when you do license, you're going to have to speak like business with the business folks, because, you know, that's what they care about. And you're going to have to, you know, help grease the wheels between the scientists speaking and sharing technical information with the business folks, and bridge that gap for them. So this is very much a relationship management position.
Absolutely. So I do feel comfortable talking about this. Christina, private message to ask about how does the salary compare to faculty or industry positions? So I will say that it's kind of the middle ground, right? I think generally the salary of tech transfer professionals, well, it depends on what level of faculty you are. It can be more than academia, certainly more than a postdoc, but it's not quite as much as industry, and there's a trade-off there. So, you know, another field, so in grad school, I decided I didn't want to do bench research anymore. So I was looking at different things that I could do, and tech transfer was one of them, but perhaps maybe consulting at like one of the big consulting firms. And some of the downsides that I found in my research, and this is going to vary, is a very personal choice, but I found that for a lot of those positions, it was a lot of long hours and a lot of travel. And finishing grad school in a pandemic, I was burnt out. I wanted a 9-to-5, 8-to-5 job. I wanted something with work-life balance. And so maybe I'm not making as much money as someone who's doing a really fancy consulting job, but the benefits, having really good like benefits, retirement, insurance, and having that work-life balance was kind of how I made that decision for myself.
I agree, pretty much the same. We're not making as much as a consultant, but we're not getting work to the bone as much either. So that's cool. And then there's still plenty of time. Like Cece said earlier, like I really enjoy going to LinkedIn and looking at tech transfer people's LinkedIn, because they're super colorful. They do all kinds of stuff. They come from all kinds of places. They go all kinds of places. And I'm really excited for, you know, what my LinkedIn is going to look like in 10 years.
And because this is a niche field, I will give a little tip, because it was kind of hard to find salary information for this field. So if you go and you Google the words Illinois Gray Book, this is Illinois, U of I salaries are all public information because it's a public university. So you can look up and see what the salaries are for folks in the technology transfer office at U of I. So keep in mind, we're in Champaign, so that's going to be different cost of living. But then for positions like Jose and myself, even though we work at a national lab, we're not federal employees, we're federal contractors. However, the pay scale is very similar to the government GS, they call it GS pay scale. And so you would be, as a PhD, like GS 11 to 13, somewhere in that range, depending on how many years after grad school and experience you have. So you can look up those pay scales and like look them up based on locality for cost of living. And that gives you a sense of the general salary for these types of positions. And I found that was really important when I negotiated my salary. So thank you to Patricia and Jennifer for the skills that I learned while in grad school for negotiating that.
If you've got time to take one more question, just really quickly. So you both did the OTM internship, but outside of that, how much experience did you have with kind of non-scientific skills like market research or patent law, versus how much of it did you get trained on from the national labs?
So all my training I got through the OTM internship. So the great thing about the OTM internship is you can have zero experience. They will train you, and those skills were really important to getting the job at the national lab. But I'm still getting trained. And so I have a mentor who's teaching me how to do my job right now at Argonne.
yeah, pretty much ditto. I did that IBC internship for a year before doing OTM, so I had some business market research skills, and then everything I know about patents I learned during the OTM internship, and actively now. I have a mentor here now, and yeah.
Oh, I see a question about what the interview process was like. I think Jose and I had slightly different interview processes. I interviewed during the pandemic, so everything was remote. But I had a first round interview, which was me and then 2 other folks, and they have these pre-made questions that they, because of the hiring process, they have to use the same questions with everyone. And then about a month later, I was called back for a second round interview, and that was with my entire team. So there was about 10, 11 folks on the call. And so it was a lot of, I would say maybe behavioral type interview questions. So asking about how would you handle different scenarios, tell us about your background in different situations and how, accomplishments and achievements, that kind of thing.
And so then I also did my interviews during the Pando, and first round was super informal. It actually kind of caught me by surprise. They kind of let me drive that interview, to be honest. So I was just asking them questions, really. And then they asked me to fill out a questionnaire. So I sauced it up and answered it good enough to get invited to the second round interview, I guess. And then the second round was I got to speak with the legal team, the commercialization team, and a bunch of folks. And then I was presented with the offer like a little bit before Thanksgiving weekend. And yeah, that's pretty much my interview process.
Yeah. I will say for mine, in case any of you do use the facilities at Argonne, having been a user of Argonne's facility for 5 years was seen as a huge benefit. They saw that as a real asset, that like, oh, this person knows, they've been to Argonne, they know a lot about the inner workings. They kind of have a leg up in terms of understanding the capabilities and of course the great science that happens there. So having that scientific research background is definitely seen as a benefit in these jobs.
And I'm also going to add, just because I know we have a person who's online who has some previous government related. So even if you've done an internship through the government or worked in the military, any of that can also be sort of an additional benefit or seen positively.
Absolutely.